Okay, so um give me a minute. Awesome. Okay, so the essence of this session is to go through the codes and just to give you a summary of what we are doing, what the code is doing, right?
Okay.
So I'm just going to start step by step. So the first thing I did was to import all the Python packages that I would use. I
Okay.
think these were most of them. So there was pandas, numpy. So all of these are Python packages to use. Then this next thing I did was to mount my storage. The reason that is necessary, I don't know. Do you need me to go through all of these lines? All the old packages, okay, fine, no problem. Pandas is used to load the data. NumPy is used in case I want to
No,
do
I
any.
I know I know those ones maybe so that we can cover the other thing.
Okay,
I'm okay with those ones.
all right. Then for modeling SKLN and all.
Yeah.
So I mounted my storage location. The
Okay.
reason was because the data itself is inside my drive. So I'm out to mount my drive here. And here I define the path to access my data. And I used pandas here to just load the data.
Okay.
I saw the shape of the data from here.
Mm.
And this is just to visualize the data. So I noticed something that there's housing cost, food cost, transportation, healthcare, and then in all of these costs. And then there's another thing called total cost.
Mm.
So what I did here was to see if this total cost here is just a sum total of all of these costs listed here.
Mm.
And in doing that, I did just the code, to do that. And I noticed that actually it's just the same thing, right? So the total cost is simply a sum of all of these costs. And it's not
Mm.
just a different cost variable on its own. All right. So after that, I did data exploration. I started by checking for missing values. I proceeded to, I saw that the median family income had 10 missing values. So the target itself for me was the median family income. I wanted to be able to predict how much the median income of a family. So, and one of the rules of modeling is that you have to drop any missing value in your target because you cannot predict what you don't know, right? So that's why I dropped it here. And then I checked for duplicates. There were no duplicated values. Now, what I did here was to do a dot describe of the you know of the values of the features rather. So I don't do you need me to explain all of these? Do you need me to explain all of these?
No, I'm saying that already. That is the describe now. That it shows the
Yes,
different the
yes,
media and the different for different all the different features. It
yes,
shows the summary, the
yes,
median, and the mean.
exactly,
This experience,
exactly. So that's what,
the
and I did.
statistical
Yes,
summary.
so exactly. So this is just for me to know the total number of unique states that I have. So United States is supposed to have 50 states, right? And then I'm
Yeah.
having 51 states, right? So
Yeah. Hello? Okay.
sorry, can you hear me?
I can hear you.
Sorry, my network is a little bit terrible.
Okay, sure.
Okay. So, um, My network is a little bit bad, so I don't know. I'm trying to. If it happens again, I might have to switch networks. Okay.
Okay.
So I noticed that this District of Columbia is not a state, or yes, it's not a state, but it is treated as a state. I think I cannot remember the explanation verbatim, but that's what I observed, right? So you look at it, the District of Columbia as a state, yet it's in our data set, right? It is part of the states listed, so that's why we have 51
It
states.
was the you.
So then I did some visualizations. These were utility functions that I used for my visualization. So instead of me to be calling this function, this code again and again, I just wrote them in a function that I can use repeatedly. So you can see, um, you can see what we have. You can see what we have here. This is the function. And these are some of the charts. I don't know if you need me to go through all these charts. I mean, this is just basically the chart. So we can see we have the function to plot the histogram and the box plots together. Here we can see if we can check the left skewness, the right skewness. I want me to explain in detail what these mean, right? But when they say something is left skew and it's right skew, from the histogram, you can see the distribution, right? You can see that this is the mode, right? This tallest bar here denotes, tells you that many households, they have the house, you know, around this level.
Yeah.
So you can see there's also another mode here, or should I say second mode, but it gets to tell you that there's a huge distribution around here, and
Yes.
then that this
Skew
there
to the
are
right.
yes, these are the outliers. You can call them anomalies that they have very high housing cost. So these are some of the things that the histogram is very good at helping you with. And so you can see, so I did it for all the features, and I explained what I was able to find. Um, looking at it, um, we also looked at. Let me go down. Um, the family median income. You can see that this one is a little bit. It's approximately normal. I will not say it is 100% normal. It is not, but you can see that
It's
it has.
skew to the right.
Yes, it is skewed to the right. Yes,
Mm.
so these things very well. That's good. So here, I think I was trying to understand the distribution of the family income across the states, right? So I said this will show us the states that has the highest or lowest household income, and I'll use three plots for this. The plot one will show us the plot for the entire 51 states. Then I'll use two plots to show us the top 10 and the lowest 10. Right. So this is
Yeah.
just different for the entire state. I did this using Plotly because Plotly is able to show you, you can see that there's a
So
difference,
using what,
right?
sir?
Plotly is able to do it in a much better way. You can see the the low.
Hello?
So hello, can you hear me? I'm
I
sorry
can hear
about.
you.
So I'm so sorry. I don't know what's happening to MTN. I'm in Nigeria, so I don't know what's happening
Okay.
right now. Um, I don't know if I should change. Oh, let's just see how it goes. We're almost done. We are we haven't just started. We're almost done. So let's see how it goes, Sha. Let me just summarize it. If it happens again, I might have to.
How do you call this kind of plot?
Yes, this is a box plot.
It's box
You
plot
can
kind
say
of
it's a
different.
point box plot, right?
Mm,
Because you're having multiple
boxes
box plots here,
for each of
right? So
the
for each of
counties.
these, yes. So for example,
The
um,
state, sorry.
yes. So you can see DC, the District of Columbia or something, right?
Yeah.
This
Mm,
tells you that they are very high compared to CO, right? You can see this is the minimum, right? This tells you that the people in DC that they earn a lot higher,
mm,
right? You can see where they are. You understand? Even some states, their maximum is not even up to the minimum in DC. You understand? And then you can see some other
okay.
states.
Excuse me, like that dish now. Why it was only the maximum? No, like you don't want to have like maximum, middle, like other. This one
Well,
doesn't.
the thing is, this is just the this this is a compressed plot. The
Okay.
reason it's like this is because of so many plots. So there's a way you can hover over this. I'm trying, but it's not showing.
Okay.
Because
Okay.
maybe because it is too small, right?
So let's move forward. No problem. All right.
If you come down here, you would see DC here. I think DC is here. You can see DC. So it's
Okay.
a very smaller than maybe because the observations
Mm.
around DC they are very small, right? We had first established that DC is not a state.
District of
You
Columbia.
understand?
Mm.
So we had first established that. So
Yeah.
maybe that's one of the reason why it is an anomaly here.
Okay.
But looking at others, this tells you, okay, these are the states that are quite low, right? And these are the states that are quite high. If you can see this is around 6,000, you can see this is 6,000. 6,000, and that's like almost half for everything, right? But then when you come here, you can see that you have these states are well above 7,000. You can see, right? So
Yeah.
that is top states, and then these are the low states, right?
Okay.
So here we're showing the distribution of the or that this is what we call bivariate analysis. So all of these ones where we are looking at, these are univariate analysis
Evaluate.
because
Yeah. Another one.
we're just exploring just
Mm.
one feature. So here now we are exploring um other features, right?
Any feature at the same
Um,
time. Mm.
yeah, two features at the same time.
Mm.
So we are looking for here, example now, we're looking at is it a metropolitan area against the family median income. So what this is going to tell us, I mean, I explained it here, right? That you can see that we had more household outside of metropolitan areas. So we had more household in non-metropolitan areas. However, it's observed that households that stay within metropolitan areas, they tend to earn higher, right? So you can see that the median family income for household in metropolitan area tend to be higher, right? Then the median family income in non-metropolitan area tends to be lower. You can see that, right?
Okay.
So
Excuse me. Excuse me. Let me ask. Excuse me. Like in this
yes,
plot now, which of the figure are we looking at? Is it this one at the middle or the top or this one?
okay, all right. So you need to understand this lowest tick here is
Yeah,
called the
this one.
minimum.
Minimum. Okay. Okay.
Yes,
Then a
this
medium.
one
Okay.
here is called the 25th percentile.
Percentile. Okay. The 100 percentile.
Yes,
Okay.
this one in the middle is called the median.
Yeah.
75th and so on is the max, right?
Okay.
So what you need to understand is this is the 50th, this is the median, right?
A medium. Okay.
On average, 50% of the people here, they don't even end up to 25%. 50% of the people in non-metropolitan areas, they
Mm.
don't even earn more than 25% of the people in metropolitan areas.
25% of those in the metropolitan are any more than the 50% of those
So
in
you can,
the
so
non-metropolitan
yes,
area.
yes. So you can say that on average, right? the people in metropolitan areas, on average, they earn more, or you can say that they have a higher likelihood to earn more.
Okay.
You understand? So this tells us that on average, we see that these people they have a higher likelihood. You can see this. This is the 70th percentile, and you can see that even the 70th percentile is even lower than the 50th percentile here. You can see
Yeah.
that. Even the 70th percentile here is even lower than the 50th. So that's like saying 75% of the people inside one house, they don't earn more than 50% of people. You understand?
Yeah.
So we
And
can,
this
so
last one is 100%, are you?
yeah.
Okay. The maximum. Okay.
Yes, but then these other ones are the outliers, right?
Outliers.
So
Okay. Okay. Okay.
yes. So you can see, so these are just the plots. You can go through them. I ensure
Okay.
that whatever plot I did, I explained the outcome, right?
Okay.
So this is also another. I think I also designed another. What's the word now? Another function for multivariate analysis. Now I'm doing multivariate analysis. So multivariate analysis tends to look at more than two variables. So now we're looking at three variables at once. The first variable is it a metropolitan area or not? The second variable is the median family income, and then the other one can be any other thing, right? So in this case, housing cost. What can we see here? You can see that people in metropolitan areas, right? You can see that they tend to pay higher housing costs. You can see that the housing cost here is higher, right? However, they earn more. You can see. So the median family income is higher here in this side. You can see that there are plenty of people here,
Plenty.
which have established that people in metropolitan areas they earn more. So that is true here, as you can see. However, the housing cost is also a little bit higher.
Yeah.
You can see. So you are living in the city, but you are still paying more in housing cost. Here you are living in the non-metropolitan,
Non-metropolitan area.
but you are paying literally, average, right? You are paying little. You understand? So we also did that for other features. In this case, the housing cost. This is okay. This is housing. I'm coming. Housing costs. Okay, so yeah, I think yeah, I changed it. In this case now, I'm no longer looking at the housing cost or anything. I'm now saying in-depth analysis of the family income against the housing cost for households in non-metropolitan areas. So now I'm separating it. Now I'm looking at people in non-metropolitan areas, right?
Okay. Yeah.
Want to know how does the family member count affect them? So you can see that people in non-metropolitan areas, right?
Yeah.
We have established before that they tend to pay lesser, right?
In housing. Yeah.
So but now we can see that people who tend to have higher family member count, they tend to pay more.
So like two parents and four children, are we?
Exactly. So you can see that they tend to pay more, which makes sense, right? You can see that
Yeah.
I mean, if you are living alone, one person, you can see that they can be earning more, right? They can be earning higher, but they are paying lesser housing
Yes,
costs.
that's right.
You can see that. And then the same thing for this, you can see that this almost a similar occurrence is what we are seeing here when we are now when we are looking for people in metropolitan areas. Similar events, people with more family members tend to pay higher housing costs. All right.
Okay.
Now exploring the cost of food. We did the same thing, so you can with this understanding, right, you can look at it. You understand?
Okay.
So
Okay.
go through these charts, except if there's anything. I'm sure we must have gone through all of these before, right? Maybe if there's
Yeah,
any
I'm going
part
to.
that you have don't want to be. So but I always ensure that I explain what I want to do. Sometimes I say exactly how I want to do it, and then I always explain the outcome, right? So if you have any question, you can just ask me directly.
Okay.
So I noticed that um, explain the cost of other necessities for different household types. um looking at this, you can see that there's something called other necessity costs, right?
Yeah.
You can see that on average, you can see this blue line. This blue line is like the mean, right? On average,
Income.
right? You
Mm.
can see that people in metropolitan households, right? They tend to pay higher, or they tend to incur other necessity costs. I think they call it utility cost, or those costs I don't plan for, right? But they are necessary for your well-being. So if you are staying in metropolitan areas, you tend to incur higher,
Yeah.
right? And you can see that. You can see that. You can see that there's a higher spread here. There's a higher spread here, right?
Yes.
And so that's basically what this is. And then you can also see that if you are in metropolitan household, you tend to pay higher tax, right? You tend to pay
Yes.
higher tax than people in non-metropolitan household. So having done all of these, sorry about that.
Man, there's no issue. Mm.
So I'm so sorry. I think prior to this time, MTN was actually very good here. Can you see my screen now?
I
Yes.
can see it too.
I'm sorry. I'm really, really sorry. Um, well, it happens once in a while. Once in a while. And I don't think, maybe if I change to another network, I don't think it's going
No,
to be better because
let's continue managing with this one.
all right, because the other network is actually
You
more
don't know what
terrible.
might come up from the other network.
Yes, it's more terrible actually than.
Mm. Mm.
Okay, so I was explaining feature engineering. I said feature engineering is simply me trying to create a new feature or a new column based on existing columns. So here I'm saying what is the net household income? Now you know that we have something called total costs, which we have established to be the sum total of all the
All the costs.
costs,
Mm.
expenses. Very good. Now we have something called the median family income. So if you have money, right, you have an income, and then you now remove your costs, right, your cost of living from it, is the output of that process, is it negative or positive? If it is negative, it means that you will likely need to take a loan for you to be able to live
To clear up, to meet up.
your normal life,
Mm.
which means much more burden on living because you now have to start paying loan, right? You have to start paying interest on loans. It means that you are closer to having, what's the word now? You are closer to living poorly, right? You are
Yeah.
closer to
Or
the
going bankrupt.
likelihood. Exactly. Now, if on the other hand you have a positive net household income, what that means is that it is likely that you can easily open a business,
Or a
you can
savings.
easily
Mm.
you can easily make your life better,
Mm.
right?
Yep.
That's why I created this net household income. So you can see I explained here the total cost is simply the sum total, right? The median is it. So it is possible that some households incur more cost than their earnings. And this kind of households have a much higher tendency to experience their cost of living standard, right? So I created a new column called net household income. And you can see I'm already having some negative values and some positive values. So you can see, what does this mean? It tells you that much more people have negative, um, they have negative net household income. You can see that it is higher in this side,
Yeah, yeah, yeah.
right? Side. And then you can see that people that tend to have very, very positive net household income, like those kind of people that they don't even know when their account is negative. They are very few, which
Very,
makes
very,
sense.
very few. Mm.
So, um, Then I explored, the states that we can find, people with positive house income, right? So these are just the top
Top 10
lowest
states.
negative. So you can see that so people in these states, they tend to have higher number of people with negative net household incomes. And then here we are seeing that, okay, these are the states that have higher people with higher positive income. So you can see DC. Look at DC now. Very few people in DC are below zero. Oh, no, there are not very few people. These are quite a number of people, right? Then this can give you an information about DC, that the cost of living in DC might actually be very high, because you can see that although they tend to earn more, but now you can see, right? Although they tend to earn more, but maybe the cost of living there is also quite high, right? So you can see that this is what we have. And then I also did some further. What I was trying to do here was to say, okay, I have all the different types of expenses. Are you with me? Can you hear me?
I can hear you now.
You're not hearing me before.
There was a time I didn't hear you for a few seconds.
Oh, please, if you cannot hear me, just talk so I can hear you.
Okay,
Okay.
okay, okay, no problem.
All right. So, okay. So, I think let me go back a little bit. You know that we had established before that DC is a place with high income, right?
Yes.
Now you can see that although this is also part of the people with the net, their net median income is high,
All
but
right.
we are seeing we also have some people that have negative earnings here, right? Like when
Yes.
you household income, the net now, like we are subtracted their expenses from their earnings,
I'm
you
getting
can
negative.
see problem. So this can tell us that maybe the cost of living in DC is quite high. Although the people earn high, but they tend to pay higher cost of living. I think somebody was discussing with me that there's a place, Luxembourg, is like that, that you may earn more, but the expenses you may
It's
incur
high.
is
Not like
so.
London in the UK. Mm.
eh,
Mm.
so some maybe DC is like that. So it's possible, but I don't know, right? Well, that's what our analysis is suggesting.
Okay.
So going further, I my analysis was to say, okay, I have all the cost of all the cost here. I have the healthcare cost, the housing cost, the food cost, and all of them. In for each observation, right? For each household, which of these costs is the highest? Which of these costs is the highest? So in household, are they incurring the high, like, is it that they pay a lot more in housing, and household B is paying a lot more in food? So I want to know which of these um expenses is highest for each of these households. If I'm able to get that for each of these households, then I can know which of these primary costs occurs the most. It can give me an insight into the prevailing cost factor, or the or how do I say how do I don't know if I get what I'm
Yeah,
trying to say.
I'm getting you.
Yes, so I want to know which of these cost factor, or which of this type of cost is predominant.
Yeah.
Understand? So this is the code that did that. So I also documented, I commented. So I said get the desired subset of the data, right, and look through each row, right? Get the maximum value for each row. Now look through the values in that column for that row. If the value for that is equal to the maximum value that we obtained earlier, like this is just how I thought about it, and I just thought about it. I wrote it down, and then I wrote the codes for that. All right. And
Okay.
so gave me the outcome. So here now he's saying transportation cost is the highest, housing cost is the highest, childcare cost is the highest, And I did my check-ins and I found out that it is actually correct. So you can see here that transportation cost in this household is actually the highest cost that they incurred. right? Here,
Yes.
care cost is actually the highest that they incurred. And if you look at the family type of these people, they have 3 children, 4 children, 2 children. So that can even make sense, right?
Yes.
So in my then I did just a count, right? And then I'm saying that okay, most of these households they spend a lot more in transportation, I mean, yes, health,
Healthcare. Mm.
transportation, healthcare, childcare, and housing. You understand? So,
Yeah.
but you must spend a lot more on transportation. Insights. If the government can do something about transportation costs, you understand, it can
Mm.
help.
Okay.
Obama to reduce healthcare costs, it can help. You understand?
Yeah.
If people can control childbirth, you know,
It
I
could help
mean,
also.
but I cannot tell people how much they can give birth. Just
I
in you understand.
understand, yeah.
So and I'm saying, okay, what do we I separated it. Okay, non-metropolitan areas, what do we have? Right? So in non-metropolitan area, we are seeing that okay, healthcare costs and transportation costs are they are very high.
Nice. Mm.
And then you see that in metropolitan areas, they are now competing with each other, right? It tells you
Mm.
that I mean in metropolitan areas, right, like this cost of living is quite high.
Yes.
So I did an intensive summary of all my insights,
Okay.
which were, and then I just wrote 2 recommendations because you know the recommendations should not be they should not be too much, yeah,
Okay.
but they can be right. But so to prepare my data for modeling, what did I do? I first removed outliers, right? That's my step one.
Yes.
My step, I get the required subset of the data that I need for modeling. Then I
Mm. All the
drop the
plan.
columns I don't need,
Mm.
right? And then I also drop the engineered features. The reason I'm dropping my engineered feature is something called multi-collinearity issues, right? For
Yes.
net household income is going to be highly correlated with either we created net household income from what's the
From
word was
the total.
from two
Mm.
total yeah, so it's going to be highly correlated with these columns. So I have to drop it so as to reduce the multi-collinearity effect, right?
Yes.
And that was what I did. So the first thing first was to drop the outlier. So outliers can affect modeling in a great deal. And first thing first, I checked for outliers. You can see that we have a lot of outliers, right?
Mm.
So I treated outliers. You can see when I've treated the outliers, you can see that we no longer have outliers here, right? Then I dropped the unnecessary columns. You can see I don't need the case ID. I don't need the state because I mean, what am I doing with the state? If I'm adding the states, the problem is that if I add the states, I'm going to have a problem. That problem is um vast data. So I'm going to have 50 more columns. So my data is going to become
Large.
it's going to be big,
Mm.
right? And it may lead to poor performance, right? So I
Yes.
dropped the county and all of those things. I dropped total cost because although total cost is not an engineered column, I'm dropping it because it was engineered. How is it engineered? It's simply a sum total of all other costs.
Cost. Okay.
It is also going to be correlated. You understand? With
Yes. Yes.
so I'm dropping it. So that's why I dropped it. Then I created dummy variables for the categorical columns that I have. Like is metro, that is it a metropolitan area or not? The count of the family member count. And you know that this feature is going to be important. How is it going to be important for us? Because you know that the higher the family size, the higher the childcare costs. So
Yes.
I believe columns would help us. So I saved the data set so that when I want to get it, when I want to read, when I want to do my modeling, I don't have to go through all this pre-processing again. So whenever I want to do my modeling, all I have to do is just read my data, right? So I selected my target and my features. So here's my feature, this is my target. I split into train, validation, and test sets. So 80% is for training, 10% for testing, 10% for validation. Now my I scaled the features. Do you understand what scaling does, or
Yeah,
should
I
I go into?
understand. I understand it.
Do you understand? You understand why
Mm.
I'm doing here and not fit transform? Yes, I
Uh,
need.
I know I've read this in before, but it's been a while. You can just 3 months a little lighter.
All right, so I'm doing a fit transform here because this is the first time I'm fitting the scalar to the data. So I want it to, you know, get the mean and the standard deviation from
Okay,
the
okay.
training. I'm doing transform here and not fit transform because I want it to use the same mean and the standard deviation that it
The fit
obtained
transfer.
set on the validation and the test set. If I do a fit transform here, it's going to compute a different mean and a different standard deviation, which is going to which is going to give us wrong output. So I
Okay.
hope that makes. I'm
Yes,
also
sir.
looking. Now I'm starting with modeling. The first thing I did was linear modeling. So I did what's it called now? What's it called? Um a minute. Utility functions for modeling, right? So I defined them. Um I also defined a function for to check the performance, right?
Yeah.
So now I started with linear regression. So I fit. So here now I'm just calling the function. This function I'm calling model trainer. It trains the model and returns the model that is trained automatically. So I
Yes.
no longer anymore. So I mean that's basically what I did here, and I observed the performance, right?
Yes.
So I did that for the validation. After training, I checked on the validation. So all I'm doing here is just to merge my output, right? So you can see that I'm just merging the results of the linear regression, right? Both on the training and on the validation, right? I did the
Yeah.
same thing for regressor, just the same thing, the same process for lasso regressor. So the only thing I just do is, import the regressor that I need, right? Instantiate the algorithm. The moment I instantiate the algorithm, I pass it into my model trainer, and that's
Mm.
all, right? So as simple as that. Um, do you want me to go over the function so I can understand what this function is doing?
Okay, can go over the functions. So since the function that we are calling that is bringing all you need to fit all
Yes.
the different models.
So this first function, model trainer, it takes in an algorithm. So you can see I have a doc string here for it. You can read the doc string. What does it do? It returns a trained model. What are the arguments? Algo is an instantiated algorithm,
Okay.
right? The train feature is the scaled train set. The train target is the train target,
Okay.
right?
Okay. Okay. And the
All it's doing
model
is that's your algorithm. You're fitting your algorithm
with
on the train
the
set.
twin features,
Yes, so that's all.
the
And then it's
train
going to
target.
return
Okay, that's
train
okay.
model.
That's okay.
Yes. So this is just to compute my adjusted R squared.
Mm.
So this is a function to compute my adjusted R squared. Yes, adjusted R squared is there is this is the if you study, I don't know how much but there's something called R squared, the coefficient of determination, and then
Dimension.
adjusted tends to penalize the R squared for using unimportant features, right? So what you have here is compute first and first, you compute your R squared, right? Then you get the number of predictors, right? N and K. I don't have it, I don't cram, so I cannot remember what N and K is. So I think it's the number of rows and number of features, right?
Okay.
So it's simple. So this is just the formula
Okay.
this is just the formula. you cannot calculate adjusted R squared without your R squared. So this is just the formula. So these returns are adjusted R squared for us.
Okay.
Mean absolute errors. This is also the formula for calculating the mean absolute percentage error.
It's okay. It's okay. You can just leave that one. Let's move forward.
Okay, so then this model performance. The model performance is just a function that computes the model, the metrics. So this computes after making prediction from the model, right? So it has prediction. So it's going to just check the target and the prediction, right? Get score. Now we already have a function to calculate adjusted R squared, which is this, right? You are calling it here to give us the adjusted R squared. The root mean square error, you get that here. The mean absolute
I
error,
mean
we get
absolute
that here.
error. I mean absolute
All of
percentage error. Okay.
yes. Then we use our results to create a data frame. This thing here, this is going to give us the type of model that we used. So if it's a linear regression, you see it here. If it's support vector regressor, it
I put
gives
it there.
us.
Okay.
So from there, just return our data frame, right?
Okay. Okay.
If you look at the result, so this is the model. So if it's here regression, you check here, here's ridge. So it changes for any regressor that you try, right?
Just yeah. I'm okay
So I
there.
did all of those things. So you can see them: lasso, elastic nets, passive aggressive regressor.
Support vector.
Literally, yes, all of them. Support vector regressor, stochastic gradient descent, the regressor. I don't know if you understand, the nitty-gritties of all of these models, what make them different. So that's what you can actually just study about that, right?
Yeah. 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 I
Hmm.
can this one I can figure those ones out from the explanation.
Yes. So all we are just doing the same thing, right? Since
Yeah.
we already have a function, we are just calling the function, right? So this trains our model, this checks our performance, right? We have another function called model performance on validation. It's simply the same thing, but the only difference is it is done on the validation set. So it's simply the same thing as model performance, but this one is now model performance on the
On
validation.
validation. Okay.
That's all we did. Then we did assemble model. For ensemble models, we choose random forests, and then we check the
Not up to speed.
performance, strategy, gradient boosting, all of those things. Then we did stacking regressor.
That progress.
Stacking regressor, what I did with stacking regressor was I said, okay, I'm going to use the top performing regressors so far. I think I found that to be gradient boosting, random forest, and then
Extract trace.
extract trees. No,
Extract
gradient
trace.
boosting. I want to use my final estimator as ridge, right? I wanted my final estimator to just be a simple model, right? So, and that was what I used here, right? And then I checked the performance. So here I compiled the results for everything, right? And then you can see, and then I think I sorted it. I sorted it based on the validation R squared, right? And this was the maximum I got upon just experimenting like that. So these were my top three models.
Yes. Hello? Hello? I can't hear you. Hello? Hello? I can't hear you. Hello? Hello? Hello?
Yeah, sorry about that.
I wasn't hearing
Can you hear
you.
me?
I wasn't hearing you for like 30 seconds.
Yeah, sorry about that.
Okay.
Sorry about that. Okay. So I did can you hear me now?
I can hear you.
Okay. So you know about artificial neural network, yes?
Yeah.
Okay. So that.
Network is fluctuating now.
Okay. Sorry. Let me see. Okay. Awesome. Can you hear me now? Can you hear me now? Hello? Hello? Can you hear me now? Can you hear me? Hello? If you can hear me, I cannot hear you. Can you hear me now? Hello? Okay, so for artificial neural network, here I just imported everything I need,
Okay. Mm.
right? I define if this function is for me to define, for me to compute the R squared, right?
Okay. Yeah.
Uh, so the first thing I did was to clear the back end. Just if you are training, right? If you are training a network, the weight tends to be accumulating at the back end. So your model may be performing, look as if it's performing well, but it's not actually performing well. It's actually um, stealing from what it has learned based on past training. So that's
Okay.
why clear and regularly clear the back end. So I built the model using a sequential network. So you can see this is just a summary of the network,
Yeah.
right? I had like 3 dropout layers with some fully connected network at the end. However, my last output was just a dense network, a dense network with one neuron, right? And my activation function was a linear activation function, right?
Okay.
So this is needed for regression task.
Okay.
So for my I designed an early stopping layer. Or no, not a layer. I designed an early stopping mechanism. Let me just put it like that. So it monitors my validation R squared to get the maximum validation R squared, right? It should tell me what is happening. I want to see what is happening inside. And patience is 3. That's after 3 epochs. I want to know if it's not performing well. I want to know.
Okay.
So I defined my loss function I want to monitor, and then I compiled the model using that, and then from there I trained. I trained my network. So you can see I trained for 30 epochs
Okay.
with batch size,
Toxin.
yes. And then my validation data, I did my validation set. I just put my validation data here. So what I did here was just to summarize my results right into a data frame, right? And then you can
Yes.
see that performance is not really good.
Mm.
Performance is really not good, right? And then you can see that the mean percentage error, it tends to be overfit itself, right? So I knew that okay, I may not be able to do well with this, right? So I decided to go back to hyperparameter tuning. So the first thing I did was to tune the x-axis algorithm. So
Yeah.
I used hyper because hyper is going to be able to help me tune it automatically. You understand? So I just gave it what I wanted to monitor, right? I designed my scope, right?
Yes.
So let me see. This is my search space, which is my scope, right? So
Mm.
I want the number of estimators to be from 50 to 100, increasing in ones.
Okay.
50, 51 to 100. And then the maximum depth to be from 5 to 50, like very much, right? And then the minimum sample split, just random, right? Like, and then I sell my trials. So you can, if you see this outfit, it was quite much. Let me see. So it was quite much, right?
Okay.
So output. Then these were my best stuff.
Result.
So this maximum depth was, it's obviously too deep. The cheese was too deep. So so um I
Maximum
proceeded to,
feature is showing 0.
sorry?
Maximum feature is showing 0. Am I saying clear?
Yes, maximum features was showing zero. Let me
Okay.
see. Maximum features. So it's either it's using auto, the square root, the logarithm, or none. So these were the only choices.
Okay. Okay.
These were the only choices here. Then I went further to to train the model with the best performance. I can see this was what I was getting. Like, it was, the performance was very high. However, the validation, on the validation set, so not so good. You can see it was not so good, like just 69%. So instead of me to use hyperopt again, I decided to use grid search. Okay, I also did hyperparameter tuning for using the random forest. So the same thing. So since this was my output, right, it was not really performing as well as I wanted it. So I decided to use grid search, because grid search is similar to hyperopt, but the thing is, grid search has that it's not fully automatic, right? It's not fully
Okay.
automatic. HyperOps is completely like much more automatic. Grid search, you tend to say, okay, this is what I want. HyperOps can search, lots. So I use grid search, and then I specify what I wanted.
Okay.
So using the best parameters for extract trees, this was what I got. The validation R square was still not as good as I wanted it to be. I did the same thing for the random forest regressor.
Of course.
What I wanted it to be. So um the same thing for stacking regressor as well. So I did the same thing for stacking regressor. I think that was what gave me, close to 70%. This was the best performance that I was getting from the stacking regressor, close to 70%. So I saved it at my best performing model, right?
Okay.
So I said, okay, since I'm not getting anything from all of these, let me tune it manually,
Okay.
right? And I wanted to use a different regressor. Now, if you go back to our summary, all of the top three models were overfitting. Only the
Okay.
gradient was not actually overfitting. If you go here, let me see. Look at this. You can see that only the gradient boosting model was not actually overfitting on the train set. This is the train set, right? 0.59, 0.58. All that were overfitting. But only the gradient boosting model was not overfitting. So I said, okay, let me do manual hyperparameter tuning on the gradient boosting model. So I started just trying, doing a lot of things, training it, like using a lot of things, changing the loss, the maximum depth, just trying to build and build and build. Honestly, just manual,
Okay.
trial and error, trying manually, right? So I started seeing improvement. You can see that now we are getting validation R squared of 0.7, right? And
70%.
then for 0.86, you can see, right? So
Okay.
this was the best optimal model so far. And then I checked it on the test set, and I'm also getting the same result. That means this model was fitting. It's actually giving a very good result, right? On the train set, I was able to 6% of the variations in the targets, right? On the validation, it
Yeah.
was able to explain 70 and 71%. right? So this was actually my best performing model, and then I
Okay.
saved it. Now for model interpretability, right? Um, I
Okay.
used I used Sharp and I used the best performing model, which is our gradient boosting model,
So this sharp
right?
is like a what do I call it now? They're used for interpreting models, have you?
Yes.
I would
So
like huh?
so what it does is like saying, okay, um, what this Sharp does is simple. It's saying how is the model getting its prediction? If the model is predicting 85,800 as median income, right? How is it coming? How does it come about? That's what that is all. That's simply what it is saying. How does it come about? And I explained it here, right? So I use different plots, right? So you can see that for these, the housing cost is telling a lot,
Hmm.
right? The housing cost is telling a lot. Transportation cost, healthcare costs. These were the major features that the model used, right? So mm, looking at the absolute mean sharp values. So this is more like feature importance. It's similar to feature importance,
Hmm.
right? This tells you that the housing cost is very crucial to the model.
Yeah.
The housing cost is very crucial to the model. Transportation cost, childcare cost. And if you remember, childcare costs and transportation costs were very important for when we did that analysis.
Yes, yes,
Like
it was.
transportation costs seem to be very important, right?
Yes.
You can see that you're actually making a lot of sense. So that's basically what I did for the project, and I was able to summarize my findings. Yes. So I don't know. Do you have any question?
Okay, okay. I mean, the presentation will come in this form, in this way, just like from the report, or more.
Sorry, I don't understand.
The slides for the presentation. Yeah, the one that will still do it,
The slides for the presentation.
No, no,
Hmm.
no, that will be sorted. That will be sorted.
Okay,
You
okay,
get.
okay, 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 okay,
All
no
right,
problem.
yeah.
All
Just
right.
go ahead.
Okay,
Yeah.
okay, okay. Okay. This sharp stuff that I used to for this interpretation.
Uh-huh.
This sharp that we use for this interpretation.
Yes.
I want to know whether any kind of guys, if I expect any kind of likely question from me because I'm not too used to it.
Well, you can look into Sharp. Sharp, this is what Sharp does, right? The
Mm.
model is making prediction. How
Okay.
are each of these features contributing to this prediction? For example, if you sum this, minus this, minus this, if you plus this, minus all of them, it should give you this value or close to this value. So that tells you that the model is using, like, this is what the model is using to make this prediction that is given to you. I don't
Okay.
know if that makes sense.
Okay.
So this value that the model is predicting for this particular household, how are each of these features contributing to this prediction? You can see it for each of them, and also for the entire features. You can see them.
The most important one.
Yeah, you can see not. I mean, you can see some of other eight features, but the most important ones, you can see that.
Okay.
Yes. So you can just that's just the basic summary of Sharp, but you can for your questioning, you can try to understand what Sharp does, to give you a little bit more solid knowledge of
Okay.
what it does. All right, but
Okay.
that's basically this.
Okay. Thank you.
Yeah, you're welcome. So do you have any other question?
With this, I'm okay. Okay.
All right, so I'm going to stop the recording now.